In this learning target, we are going to be able to graph an exponential function given its equation. So what you need to know, the exponential parent function is f of x equals b to the, and b is called the base of the exponential function. So when that value of b is between 0 and 1, or you can think about it, it's a fraction, that's going to be like 0 point something when you type it in your calculator to convert from a fraction to a decimal, the function shows exponential decay. So the graph is going to fall from left to right. If your value of b is greater than 1, the function is going to show exponential growth, and the graph is going to rise from left to right. So let's take a look at graphing a couple of these types of functions and whether or not we have examples of exponential decay or exponential growth. So in example 1, we have the function f of x equals 2 to the x. So right away I notice that since I have a value of 2 for my b, this is my base value, okay, and my b equals 2, that's greater than 1, which means we're going to have growth. So when I graph this, I should show growth or an upward curve in my exponential function. A table of values is really helpful when we're graphing exponential functions, and you're going to need more than just 2 points. Like when we graphed a line, 2 points was sufficient. We could just plot 2 points and graph. But when we have an exponential curve, we need more than 2 because we need to see where that graph is going to head upwards to or downwards to, depending on if we have growth or decay. So graphing technology like desmos.com/calculator is a great resource. This is something that is shared often in your class. So make sure that you're utilizing this if you don't have a calculator with a table function. But this is what you'd get when using a table. So here are my x values, -1, 0, 1, 2, and 3, and I've just picked 5 values. We typically start right around 0, including maybe 1 or 2 negatives. And then each of these inputs or these x values has been evaluated into my function. Okay, my function was 2 to the x. So this is how we got the answer. We plugged in -1 for x, and that gave me 1/2. Okay, I'm plugging in 0 for x. That's how I get 1 for my answer. I'm plugging in 1 for x. So 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. That's where the f of x terms or your y values are coming from. So when I graph this in a coordinate plane, here are all of those values, and we can see that that curve is growing upward, which I already identified at the beginning because I saw that that b value was greater than 1. And you can also use that desmos.com/calculator to graph your curve so you can see exactly where those points would lie. Okay, so we have a second example. If you want to try one on your own and then come back and check, we have the function f of x equals 3 to the x. So just like before, my b value again is 3, which is greater than 1. So I'm going to have an example of growth when I am drawing my graph. It's always a good idea if you're not sure how to graph something, just to use that table, regardless of the type of function you have. So pick 4 to 5 points that are on the graph of the function, and then you can plot them and graph your actual function. You can use whatever x values you'd like, but again, we like to stick near 0 when we start, just for consistency and because our values are going to grow rather quickly with exponential functions, and your coordinate plane might be difficult to label if you use too large of numbers. So here again, I evaluated my function at each of these x values. So this was like 3 to the -1st. This was the answer for 3 to the 0. This was the answer of 3 to the 1st. This was the answer of 3 to the 2nd. That's where we're getting all of those f of x values, which are really my y values when I graph them. So once you've found your table, you can go ahead and plot those points and then draw in your curve. Or you can use that graphing technology available at desmos.com/calculator for you. And then this little note here, it says even though it looks like the graph is touching the x-axis, remember that it's not actually touching it. It's getting really, really close. That's the asymptote that we'll talk about further when we talk about the features of our graph. If you want some more information on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.